Okay, I want to talk about the number 9.8 because everyone who takes physics has heard 9.8 or sometimes 9.81, and they use it, but they use it almost indiscriminately for anything and everything. Like, I don't know what this number is, I'm going to use 9.8. And that's not what it means. So I want to be very clear and specific what 9.8 really means. Number one, 9.8, we want to put a 1 in, that's fine. 9.81 meters per second squared is equal to the acceleration of a falling object, as we've seen in free fall, or a projectile. Now, if we haven't talked about projectile motion, just keep in mind a projectile is something in the air, right? It's not touching a flat surface. It's not being pulled or pushed by anything. And as long as we ignore air resistance, any projectile or free-falling object, anything that's just in the air by itself only has one force on it, and that force is your weight, F sub g. So because of this, all objects that are projectiles have an acceleration of 9.8 meters per second squared. I'm going to add that it is a vertical acceleration too, because gravity only pulls down, right? So the acceleration is downward. You can express this as negative 9.8 meters per second squared if you want. That negative can indicate a downward direction. You don't want to say negative 9.8 meters per second squared down, because technically the negative would counteract the down, so it becomes negative down, which would imply almost like two negatives and then therefore going back up. So just be a little careful with it. But 9.8 meters per second squared down, or negative 9.8, acceleration of a falling object. Another thing that it can be used for, 9.8 meters per second. So I'm giving you a different unit. It looks the same, but it is in fact a velocity. So let's think about it. If we drop an object, the instant it's dropped at time equals 0, the velocity is 0. But it has an acceleration of, oh, this is a mistake. What did I say? Well, it's not a mistake. It's just a little confusing. Okay. I'm not trying to say the weight is negative 9.8 meters per second squared. I'm trying to say the acceleration is negative 9.8 meters per second squared. So if we drop an object, and there's certain kinds of projectiles that we launch as well. Like if we launch a projectile sideways or horizontally is what we call it, its initial velocity vertically is 0. So that means because its initial velocity is 0, after 1 second, its velocity is changing by 9.8 meters per second every second. So after 1 second, it's going at 9.8 meters per second squared. Sorry, 9.8 meters per second. After 2 seconds, it's going at 19.6 meters per second. After 3 seconds, it's going at 29.4 meters per second. So every second it increases in speed downwards by 9.8. So 9.8 meters per second is the velocity of a dropped object after it's been falling for 1 second. The final thing, 9.8 meters per second squared, is equal to this constant g, which is the magnitude of the acceleration due to gravity. And this is a constant, right? So this, unlike the previous two things, which were vectors, this is a scalar technically because it's a constant. And we use g for a few different things, like when we want to find the weight of an object, we say it's equal to mg. So that's really where g comes in too. It's a constant that we use for some things such as finding weight. Other than that, can you have 9.8 meters per second squared elsewhere? Yes, definitely you can, but it really doesn't come into play all that often. Most of the time, if you see 9.8, it's going to be for one of these three things. That's about it, right? So if you're just picking 9.8 meters per second squared as a number to fill in for something, ask yourself, hey, is this a projectile? If it's not a projectile, is it the velocity of a falling object, right? Both these first two have to do with objects that are projectiles or dropped. And the third one is for weight. So if you're not computing weight or mass, and you're not dealing with projectiles, you probably shouldn't be using the number 9.8. Thank you very much for watching.